Okay, we're recording that. Okay, so we're recording now. So anything I say or can be used against me in potential courts of laws in the future, I guess. Typically, I'm not going to have the camera on. Since we're not meeting at all face to face, I thought you deserved at least one face to face jazz hand look. Typically, it'll be camera off because it takes a bandwidth and storage space and slows things down. But I thought I'd just give one brief so you know who I am. So if by some chance you are on campus and see me in the hallway, you can say, "Hey, Mr. Egg, how's it going?" It's my typical dress. I do teach off camp. I am on campus still, so I do get dressed up. So I do worry about bad hair days still. I do worry about my clothes matching, but comfortable. So this is my typical wear. Sometimes I'll wear a t-shirt. If I'm really adventurous, I'll wear a t-shirt that's not an NWTC logo shirt. Usually math related. Although I do have one. Maybe I'll wear Friday. I'll punch it on. It's a really describes my entire attitude for this year, 2020, being a dumpster fire. So I'll show it to you. I'll wear it on Friday and I'll show it to you. Just because you're the probably like you, it's the only class I have on Friday that I need to teach. Okay, okay, looks like we have everything we're gonna have on. So I'm gonna shut the camera off. Ding. Go to share screen. There. Okay. Here we go. Chat. So I have the chat open on the side, so if you need to get my attention, just shoot chat in. Sometimes it may take me a minute or two to see it, even though it's 6 inches off my viewpoint, my peripherals, or just go off mute and say, "Hey, Mr. Egger, question, whatever." It's Math and Logic, so welcome. I see you all. Well, most of you looks like you successfully got into the class. I presume via the link that I sent you via email. I won't be doing that any longer. That was a one-time deal. So for future, what I need you to do is launch Blackboard. I'm going to same view you have. Go into Blackboard, and you're going to come up on the announcement page. That's fine. But for the class from here on in, you're going to want to look at this here WebEx Virtual Classroom. In that little pull down, that little, I don't know what you call it, folder, all you need to do is just click on it, and you have a different view, and I'm a host and everything else, but you're something similar, but you should be able to go in and it will say to join or something like that. So they'll be all listed here. So I have this week's, so there's Wednesday and there's Fridays. So Friday's already, uh-oh, didn't want to do that. That's easy to fix. Just got close. So you just want to go in here and whichever one says to join, do it that way. I always do that. Okay, so go through there. Okay. Now, in full disclosure, I taught this class spring, but when we went to 8 weeks, there was a huge course redesign. So in many ways, this is like my first time teaching this class again. And it's really a little bit on the, I can't think of a good verb that doesn't sound derogatory. let's just say this is my last semester. I'm retiring at the end of the semester, so to have to learn how to do a whole course for one semester is a bit of a challenge. But we will get through it. And I'm looking at the camera. I know it's not doing anything. We will get through it. So let's figure out how this course is going to work. How we're going to do this course. Because it's a little different. I usually don't go this kind of detail, but I think it's needed. So let's just go looking down. We have the announcement. Cool. We have how this class works. All right. There's the next one below announcements. And I thought I had the edit mode off. Okay, here we go. This is what you see. So question how you succeed. A lot of questions in it. Academic coaching. So please read this one. Facebook grades. We have homework. We have like 2 discussion boards, a midterm and a final. Okay. No extra credits, no curving, basic 60, 70, 80, 90. I believe the book that you should have. I guess it's not. I guess this is now gray. It was blue. Now it's gray. And I'll be needing you to do some page checking for me because I don't have the current edition. I turned mine in and the spring, and they can't find another edition to loan me. So I have an older edition, which for the most part is still good, but the numbering is all out of whack now. So I need to get the numbering so I know what to look at. So here's a textbook, which you should have. Calculator, just a standard TI 30. We're not going to do any kind of fancy math other than multiplication, dividing, division, adding, subtracting, stuff like that. So do read over how this class works. Syllabus calendar. Essentially, the syllabus is, for the most part, not going to change much. Who I am, my office is going to be virtual because no one's allowed on campus. We're not allowed to meet with people on campus. So basically, telephone, my email, and structured availability by appointment in Starfish, or by email, or by a phone call. And what I can do is set up a WebEx type conference for talking or for discussing, doing problems if need be. Class delivery is all virtual. Technically, this is a blended class, and what that means is typically it's a 3-credit class, which means there should be 6 contact hours, generally 6 contact hours a week to get it up to 45 hours. Well, 45 hours in the 8 weeks. And look at the time, we're a little short, we're like 45 hours. So it's 3 hours that the intent is, well, you'll be doing some more work on the outside of class. Technology, what? Computer, yeah. CompSys, I'll let you go through this since most of you have already done syllabuses before. I think everyone should have. All right. What's going to change? I can tell you right now, multimedia presentations, we're not doing them. The shell that I was given was created by another instructor, and looking at things, I just can't find where they are. So we will have problem sets, 13 of those. We will have quizzes. Notice there are 5 quizzes. But the basics for practice, the prep for the test. 2 discussion boards. Introduce yourself and Muskergy's POV. That's about halfway through the semester, so we'll discuss that when we get close to it. And 2 exams, a midterm and a cumulative final. Problem sets will be big. Like I said, the multimedia presentation, disregard, I'm going to take that out. Discussion boards and exams. All right. Rubrics for discussion board, come on, calendar. All right, calendar. All right. Calendar generally is okay. I think that some of the dates can be adjusted. I'm not going to put any dates in. I think I'm going to move some of the dates out, mainly because I'm not going to do the multimedias. That kind of like opens up dates for having due dates in and for more time for me in class to do demonstrations. But it's a tight schedule. I mean, basically we have 4 learning plans, or 5 learning plans. So roughly, some learning plans are 2 weeks, some learning plans are 1 week. And some of them are pretty intense, particularly learning plan 2 and learning plan 3. So that's 4 weeks out of the 8 that are just doing logic stuff. The midterms and the final will be not exactly on the line. They'll be made available online for you to basically to download, do, and then resubmit, upload into a Dropbox for the assignments. All right. And one's due on Wednesday, just before Thanksgiving. Hey, wait a minute, 23rd. We don't meet that day. I gotta change that date. And it wouldn't be on the last day of class on the 18th of December. Blank page. Oh, nice. All right. So that's a course syllabus, and the calendar is just that page pulled out. Okay, syllabus calendar. So that's great. Now, 2 things we're mostly working in is something called learning plans. Okay. And so please read this on how to use it because it looks a little weird. What's going to happen is do a learning plan, and you have to literally go through pages. So page 1, understanding. All right. If you just hit the next one, it'll get through to another page for looking at patterns, and then techniques of problem solving by George Polya. Okay. So a lot of these links are going to be basically go through. I'm not going to go through these guys all the time. Maybe some of these I will. All right, but a lot of them are going to do other problems that I have elsewhere. So we'll be doing some work in here. And the other big areas we need to look at is the assignment section. Okay. This is going to be based on the homework area. Okay. So the first discussion board you have is going to be this guy. Introduce yourself. Okay. All you need to do is basically just click on it and start a thread. Thread edit. Oh, Harvard's fitting down. How do you create a thread?
Isn't it on the top left right there?
Top left.
You gotta like press back.
Yeah. Oh, create thread. Here we go. Yeah. Create thread up here. You just gotta type in your response to the question that was being asked there. And what's being asked again? Let's go back to class material assignments. Click on the button, open discussion and left navigation. Oh, introduce yourself. Kind of light on what they wanted. Let's see what this example is. Okay, well, looks like where you were born, your goals, secrets for online, diverse. I think I need to get some more information put on what's wanted. I do apologize for that. I'm trying to, some ways, learn this or board as much as you all would be doing. So I got that, and it's like says, a little pretty open on what I'm looking for. Problem sets. And we talk about homework. The problem sets, and those are based process 1, 2, 3, and so forth. And the actual problem sets, you're going to have to kind of like open them up, print them out. Okay, print them out, and well, here's the problems. One question, one with 10 points is answering these 5 definition questions out of the textbook. Then on separate sheets of paper, answer question from the textbook. Chapter 1, problem set A, problem 5, 6, 7, 10. Chapter 2, problem set A, problem 3, 6, 7, 9, and 12. Okay, so that's what would be turned into me. Kind of what I'd be looking for in grading on the problems, on the problem sets. Systemic list is chapter 2, diagrams is chapter 1. Okay. So the chapter 1 rubric right there, and chapter 2 rubric is the next one down. Okay. Let's see what else to talk about. Oh yeah. Now what I need to know, once we're on the list here, hopefully someone has the textbook. So I'm looking, I would need someone to open the textbook, the problem set A for chapter 1. And it's probably somewhere on page 19, 20, 21. And if you just read off for me, what is question 5? I just need to know the heading of it. What question 5, 6, 7, and 10 is out of section problem set A of chapter 1.
Stone necklace?
The problem 1 is stone necklace. Okay.
Oh no, sorry. That's Warm Journey. Sorry about that. I thought you said 5.
Yeah, I do need A5.
Oh. Yeah, problem set A, number 5 is Stone Necklace, I believe.
Okay. And 6.
Do you still want me to do this one or someone else?
Oh, that's fine. Just
Dangerous maneuver.
Yeah.
dangerous maneuvers.
Yeah.
And 7.
It's called race.
Race. All right. And number 10.
Rock.
Rock climbing.
Oh, okay. Those basically the same as in the previous edition. That hasn't changed none. And then for chapter 2, problem set A. Number 3.
Number 3,
Yes.
free concert tickets.
All right. And 6.
Nothing change.
Huh. All right. 7.
Finished product.
9.
3 errands.
What was that card again?
3 errands.
3 errands. Okay, I don't even have that one in my book here. Look that one up. 3 errands. And the number 12.
24.
24?
Yeah, that's actually what it's called.
Yeah. Now, that one's number 9 on my list, and I don't even have 3 errands, so I'll have to look that one up and I have to search that one. 3 errands. Fine. Okay, thank you. I do have an order to get a book in, so hopefully it's not all semester doing this. But if it is, my last semester, hey, you know, the dumpster fire semester, so why not? Thank you. All right. Okay, now, so for these problems, I mean, okay, so you print this guy out, you work the problems, like problem one, you type out, 2 through 10, you got, do by hand on a sheet of paper. So how do you submit them? Well, the other link above it, the problem where it says problem set one drawing, that guy, just click on it and boom, okay, get this guy. Oh, there's the problem again, in case you need to find it again. Okay. All you need to do is, if we're face to face, I would just collect it, okay, but we're not. Done. So we have some kind of electronically submit it. So if you have your hand typed out and or handwritten solution is the problem set, you can either use your phone, have a like a PDF creating app on your phone, so you take a picture of the page and turn it into a PDF file. Be nice to have a 30-page PDF versus 30 individual pictures, but download a PDF app from your phone and print it out, or make a PDF copy. And once you, or if you need to, individually with your tablet, with your phone. If you have a printer scanner at home, that's even better. Just scan it as a PDF. So a picture or PDF, just basically you attach a file to it, and hey, here's my PDF for it. Okay, there's one file. I also have to do some of them are pictures. Some of them are pictures. I mean, pictures up here somewhere I do. I've got a Word document. Okay, there's my Word document part of it, and I have a picture also. Here we go, picture, okay, JPEG. Just keep on loading them in, as many as you need for the assignment, and then just hit submit, and it'll go into Blackboard as an assignment for me to grade. And again, I'll be in full disclosure. These guys take forever to do. Oh well, such is life. So that's how you would submit your homework assignment. You need to either make it to a PDF copy or a JPEG or a Word document. However, do avoid the weird extensions. If you have an iPhone, sometimes they have a high density compressed photograph. I forget what it is, HEIC or something like that. I can't open those. It's a Google Doc. I can't open those. If you have a computer that attaches some weird, funky, I had a student last semester. He kept on. It was something dot PDF, which is fine. And it was like a MBL, HTML, a bunch of other extensions to it. And again, because of that, I couldn't open it. So I'm looking for DOC, JPG, PDF, whatever Excel is, the standard type documents for me to be able to open and review and assess. Can't stop, because I screwed up and actually sent those files in. So let's go into problem sets. And right now, for like problem set 1, I'm thinking Monday. Between today and Friday, I should get through chapter 1 and chapter 2 material. Okay, got some chats here. Does it have to be handwritten? We do the homework in Word document. Should we be ready to? Okay. Does it have to be handwritten? No. It's just that diagrams. I'm not sure how you can do a diagram. I suppose if you have like kind of like what I do on board here. If you have like a tablet that you can draw and put your work in, much as kind of like what I'm going to be doing. Yeah, that's fine. And so long as it's a document type that I can open, because even like what I'm going to do with the smartboard here, I'll convert to a PDF before I load it in the Blackboard for reference later. But if it's in Microsoft, if it's a Word document, that's fine. You don't need to convert it, because I can open Word. And as far as being handwritten, I'm not quite sure what that means. I'm assuming you mean like I'm assuming diagrams and likes. The answer is no. If you can do it electronically, that's fine. Not a problem. Like I said, I don't always get the chats right away. I do eventually see them. Okay, so we're spending a lot of time in here for assignments. Okay. And the last part that we'll be spending time in is in the exam section. Well, actually, I got to load the exams. Just the information exams. I will eventually load exams in here, but it'll be closer to the time that we will be doing the exams. There are 2 sample exams. We've got the midterm and the final exam for last semester, spring 2020. There are new exams for this semester. And like I said, the second example, I'm not going to impose a proctor exam location because the assessment center isn't available. Okay, so I'm going to go a lot on personal integrity and of honesty that the work being done is by you and you alone. Not search the internet for answers. Now, while you're doing the test, can you use your notes? Yes. Midterm 2 hours. Yeah. Can you use homework assignments for reference? Yes. Can you use textbook for reference? Yes. I'm not going to restrict you to that extent. But I do definitely put a plea or a stress in that it is your work and not go Googling the questions on the internet to find the answer to it. But we'll discuss that more when we get closer to doing a test, which is still at least 4 weeks out. Let's see. So back to learning plans. So in learning plan 1, and like I said, the warm-up pattern recognition. We're not doing patterns yet, so I'm gonna hold off on this guy until it's more appropriate when we're in that section. And I'll let you guys read these things on your own. So I want to get right into what my my presentation. Just got to find it now. Oh yeah, it's right here. We have 2. We have chapter 1 which is drawing a diagram, and we have chapter 2, which is systemic lists. Kind of descriptive. One is solving by a picture, a drawing, a sketch. The other is solving by making a list and checking it twice. Oh, long time you're getting there though. Okay. So draw a diagram, and I'm going to add one to this one too. It's usually one I get for homework. But I saw real quick she had it in her sample one, so we'll do that in class also. Since I think we'll have enough time. Okay, if we do okay, nothing new in the chat, so good. So let's look at this guy here. I'll give you a minute to read it. Okay. That's a bunch of people that are doing a fantasy basketball league. And the thing to get out of this is they're going to play 3 games between each of them, which means the Eggs will play the Badgers 3 times, the Cornhuskers will play the Gators 3 times, the Ducks will play the Falcons 3 times, and so forth. So looks like we have how many teams? We have 1, 2, 3, 4, 5, 6, 7 teams. And just coincidentally, it's basically like an A, B, C, D, E, F, G type abbreviation we use. Okay. So 3 games each, or 3 times on the block. I have 7 games, or 7 teams. How many games played in all? So let's see, we have 8. Let's put one in the middle. So a diagram. A, B, gonna be 2 out of these, 2 horizontally. A, B, C, D, E, F, G. A for Aggie, B for Badgers, D for Ducks, G for Gators, whatever. All right. So one way of doing this is to notes. Is do a line diagram. So let's see. Obviously, team A is going to play team B. Then team A will play team C. Then A will play D. A will play E, F, and G. So just the A team playing all the other teams will result in 1, 2, 3, 4, 5, 6 games being played just by A alone. That's just one time, times by 3. And how about B? Well, B will play A, but wait one. B playing A is the same as A playing B. I'm double dipping there. But really, that one's already taken care of with A. Okay. Now then B will play C, D, E, F, and G for additional. Okay, the game between B and A was covered by A playing B. So there's another 1, 2, 3, 4, 5 games played that are unique. A playing B is no different than B playing A, so those were not a unique game there. All right. How about C? Well, C playing A, that was already taken care of. C playing B, that's not unique. But C playing D, playing E, playing F, playing G for another 1, 2, 3, 4 games. What's next? Well, let's see what D plays. Well, D played with A, that's A versus D, and D with C, and D with B. 1, 2, 3 for 1, 2, 3 games. All right, this is getting messy, so I think we start seeing a pattern here. A gave us 6 games played. From B, we got what? B is what, green? 5. From C, we got 4 additional unique games. 4? Yep, 4. For D, we got 3 unique games. A, B, C, D, E, F, G. So from the pattern, I think we can pretty much now do a pattern that E should only be 2 more games. We'll quickly prove that. 1, 2. So F should just be 1 more game. And from G, poor G has already been taken care of by all the other people. So we add them all up, we get what? 6 and 1 is 7, 5 and 2 and 7 is 14, 4 and 3 is 7, that makes 21. So we have 21 links, or 21 pathways, 21 ways, 21 combinations of unique games. 3 times, so let's probably be 25 games total played by those 7 teams. 7 times 3 squared. 9 times 7 is 3. Well, that's a pattern. Don't know. So that's a little convoluted. But that's basically a way of doing it by diagram. Is find the unique links, the unique combinations that weren't done before. Like I said, A and B is the same as B playing A playing C is the same as C playing A. Same as handshakes. Now another way, which to me I think is even a little more even burden. A, B, C, D, E, F, G. Same idea, except we're going to do it instead of doing by little loops, do straight lines. And of course, that's how many. A gave us 1, 2, 3, 4, 5, gave us 6. 6 lines. Now from B, okay, well that's already been done. Now I got 1, 2, 3, 4, 5. 5 unique pathways. See? Well, that's been done. That's been done. Now we got 1, 2, 3, 4. Another way to find the unique pathways. C, let's check out D here. The D is, that's been done. That's been done. That's been done. So we have 1, 2, 3. 3 pathways that weren't done yet. And again, looking at E, it looks like all we have left for E is E to F, E to G. Everything else has been done. One F to G, and then from G, there is no path that has not already been G to A, done. G to B is already covered. G to C is done. G to D is done. G to E and G to F. Again, add them up. 7 and 7 is 21. 21 times 3. 3 games each. 63. So that's another way to do it. And for either one of these, having different colors to show the different pathways does help a lot. But either one of these 2 methods would have been a viable way of doing this problem by a diagram. Again, by diagram. There are other ways of solving this problem. These are 2 ways that are predominantly shown for a diagram type solution. You can recall what the question was. The question was, we had 7 teams playing each other 3 games. And so how many games would have been played in all? And the kicker is A playing B is equivalent to B playing A. All right. So, no new chats coming up, so I guess maybe it's not as clear as crystal, but at least it's not total mud so far. Let's see. Look at this guy. Esther's model train is set up on a circular track. 6 poles spaced evenly around the track. Go from pole 1 to pole 3 is 10 seconds. Question is, how long would it take the engine to go all the way around the track? Believe it or not, this is a problem that people have issues with. So the thing to get out of here is circle 6 points and a time to go from one pole to a different pole. So I need a circular track, I need 6 poles, and a time between 2 poles. So on a diagram, let's do this. Let's make a circle. And let's put in 6 poles. And let's number them. Pole 1, pole 2, 3, 4, 5, 6. And I gotta check on, yes. Evenly spaced, that's important. Because if they're not evenly spaced, nothing won't work. So I have a circle, I have 6 poles, kind of sort of evenly spaced around the track. Best I can do by hand, all right? And I'm not gonna do that perfectly. We were told to get from, so choo-choo, go on the track, passes pole 1, goes to pole 3, and it takes 10 seconds. Visually, okay, yeah, so that means 1 to 3 was 10 seconds for 2 poles, which really means going between 3 poles. I guess if I look at, here's another even equivalent space. Basically it's 1, 2, 1, 2, 1, 2. There's another equal space. Now, assuming the train is going the same speed, not changing speed, go from 3 to 5 should be 10 seconds, and 5 back to 1 should be 10 seconds, for a total of 30 seconds around the block. Is this the only way to do it? No. Again, it's got 6 poles. 1, 2, 3, 4, 5, 6. And let's number them 0, 1, 2, 3, 4, 5. Still 6 poles. Some people like to start at 0. The key is 0 is one of the poles. Don't go 0, 1, 2, 3, 4, 5, 6. Let's do that. You have 7 poles. But still, you got your choo-choo. He passes pole 1. Passes pole 3. That's 10 seconds. And visually note that, hey, all these, passing every 2 poles, so passing pole 3, the pole 5 should be 10 seconds. And 5 back to 1 should be 10 seconds going through 0. Again, you still get 30 seconds. And there's another way of doing that. Don't know if I can figure it out. So a choo-choo train go on a track around 6 poles. Either way it works. Either way would work. Yeah, what's going on? Yeah, just grab there then. That'll work. All right. All right. Again, remember this is a diagram. We can do diagram to create a visualization of the pathways, which is what these 2 guys did. uh, a figure to lay out the geometry of the problem. And from the geometry, you could visually do the algebra on it. And in this case, we recognize 3 equally spaced arcs, 10 seconds each. Of course, then do add 10 up 3 times, 30. 2 ways of doing that. And this one here is going to be a geometry problem. The diagram be laying out the geometry of the problem. Be able to go from a verbiage to fact. And of course, picking out the fluff. Curly used a shovel to dig his own swimming pool. Yeah, right. Need information? Nah. Don't laugh, because I actually had a friend who it was a full summer project, but he wanted to dig his pool deeper. He had an above ground pool, but he wanted to have slightly sunk in by a couple of feet, and he hand dug out I don't know how many cubic yards of clay. It took him all summer, but he did it. I guess they want to pay for a backhoe to come in to do them in one day. Now he figured he needed a pool because digging it was hard work and he could use it to cool off after working on it all day. That's one shallow pool. But again, not needed for the problem. He also planned to build a rectangular concrete deck. Do you plan a deck, or do you plan on building, or do you pour a deck? A rectangular concrete deck around the pool that will be 6 feet wide at all points. All right, that's important to know. So where the pool is, where the pool edge is, will go out 6 feet all the way around it in a rectangular fashion. And finally, the pool is rectangular, measuring 14 by 40 feet. Okay. Always remember what is being asked. What question is being asked? The question being asked is, what is the area of the deck? All right. So, geometry. Okay, so, here's my pool of dimension 14 by 40. And then we're doing a good enough. Where 6 feet here, 6 feet there, 6 feet there, 6 feet there. Which is going to make that dimension how big? Well, I've got 6 feet, I got 40 feet, and I got another 6 feet, which adds up to 40 plus 6 is 46. 46 plus 6 is 52. And I also have an outside dimension of, well, 14 feet plus 6 plus 6. 14 and 6 is 20. 20 plus 6 is 26. So now I got two geometries. Rectangle inside a rectangle. And the question was, what is the area of the deck? Well, that's all the blue stuff. Now we got to come with a strategy on area. Oh boy. So many ways to solve this problem now. 6 equals 26. Oh, yes. Did I miss something? How many said that? I think I was talking about, yeah, 40 plus 6 plus 6 is 52. 14 plus 6 plus 6 is 26. Yeah, because that and that makes 20. Yeah, 26. Yep. All right. Now we can look at it as three ways. And each look at the area of deck is the area of the big rectangle minus the area of the little rectangle. Basically looking at the idea of negative space, the pole being negative space. So it being negative space, we subtract it. And if that's all you did, you'd be fine. The diagram was to set up the geometry for the strategy of getting your blue area. Yeah, even use blue pen. So basically whatever this is, yeah, not 26 by 20, 26 by 2. There's a little dyslexia there. Minus 14 by 40. And I think that gives us something like a 1352 minus 560 or 792 feet squared for that problem. That's one way of doing it. Oops, there you go. Big rectangle minus little rectangle. Well, it was in red. Well, could I also have oops. Turn it into Oh, the other pin's up. Gotta put them both in, I guess. There you go. There you go. Area deck would be what? Well, I got I created two rectangles. That looks like a 6 feet by 26 feet. Basically this rectangle. And two rectangles that are, well, 6 feet by 40 feet. Basically, that one and one opposite. And if I done it that way, I think this guy becomes 312 feet squared. This is 480 for a total of 792 square feet. Hey, same answer. Same answer. Uh-oh. I'm not going to draw it on here, but we also of done it that way also. When I've had two 52 feet by 6 feet and two 14 feet by 6 feet. That worked. Two 6 by 52 plus two 6 by 14. And this gives a 624 plus 168 for son of a gun. 192 feet squared. So there's more than one. So even with a drawing, there's always more than one way to do a problem. Like some, you may recognize, hey, big rectangle minus little rectangle. You may recognize, turning the outer edge into four rectangles and doing it that way. And either way, you've been right. So when you're doing the homework problems, it's important that you convey the process, not just the solution, but the process of the sketching, the synthesis of how you want to do it. And then, of course, then the number crunching. But the diagram set up the algebra for doing the problem. Farmer Ben. So let's see what we have here. I'll give him a minute to read it. We have a farmer and he has two animals. He has ducks and cows. E-I-E-I-O. Okay. So he has ducks and he has cows. Those are horns. Looks like an ant. Leave it like that. Ducks and cows. Okay. And let's see, he doesn't remember how many he has, but he knows he has 22 of them. So whatever the number of ducks are, plus the number of cows, has to be 22. And he also knows why he remembers this beats the heck out of me. That when I total up the legs, I have 56 legs. Question, how many ducks does he have? How many cows does he have? Now, yes, there is more efficient ways of doing it algebraically, but nowhere near as fun, I guess, sketching it out. So we know we have 22 animals and 56 legs. So let's think about it. If we were all ducks, and there was 22 ducks, we'd have 44 legs. Now that's too small, so obviously it can't be all ducks. If we're all cows, that means 4 legs. That would give us 88 legs. Too many. We got to be somewhere in between 22 ducks and 22 cows. Okay. So let's do it by a sketch. Yes, we can do it by algebra. Okay. And that's also very important because you read the rubrics of grading, that is very specific that, yes, if it's a diagram problem, but you get the right answer, but you use a method other than a diagram, 0 points. So when that happens. So what do we know? We know we have 22 animals. I also know I'm somewhere between 22 ducks and 22 cows. So let's start with 22 ducks. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 20, 21, 22. So let's make more ducks. Now, the perfectness of my sketches here is a hint on how perfect I want you to have your sketches done. Okay, got 22 ducks. I'm going to leave off the bills. So 22 ducks. So 22 ducks. All right. So I know that's 44. So let's keep adding legs on the ducks, trimming the cows until we get to 56, is it? 56. So 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. So it looks like I have 5, 10, 15, 16 ducks. And 1, 2, 3, 4, 5, and 6 cows. And for a quick check, 16 times 2 is 32. 6 times 4 is 24. And I'm up 56. So that's about the only way I can think of doing this graphically. Although I guess we could have started with our cows and started subtracting legs. And we could have started with our cows and then started turning cows into ducks by amputating the 2 front legs. Okay. And again, to the perfection of this sketching, this drawing is my expectations of your sketches and your drawings. You can do better, just can't do worse. And mine are pretty bad. Okay. What happened to it? I know I put that in. Where did I put it? I had another problem on here. Obviously, I'm missing something. You go in the wrong section? I'll just put it real quick. There you go. All right. Now look, we can do by diagram. Yes, you can do by algebra and all that other good stuff. But it says in a theater group, there are 8 more women than men in a theater group. Group has a total of 44 members. How many men and how many women are in the group? All right. So 8 more women. So women is greater than men by 8, which means that they're not equal number-wise. So one way, a strategy for doing this graphically is to first start with equal number of women. Well, 44, they're equal, they'd be 22 women, 22 men. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right. And 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Whew. Men. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And again, another 11. 6, 8, 10, 11. Okay. So now they're even. 11 men, 11 women. So 11, 11. So let's start changing some men into women. So to make this guy, that one a woman, that means I will now have 12 women and 10 men. So I changed one. Now that means, so now I have 2 women, 2 more women than men. Change one person, change one man into a woman, and now I have 2 more women than I have men. Well, 2 for 1. Well, let's do that there. Let's do another one. Change the second one into a woman. So now I have 13 of those guys and 9. $22 we start with. So now 21, 23. Change another one. Now we have 24 and 20. All right, so 44. All right, always as with the 44. So now I have 20, 20. Now there's 4 more women than are men. There's another one. Now I have 25 women, 19 men. That's 6 more. Do again. So now that gives me 26 women, 18 men, which is now 8 more. How come, I mean, why is that? Why am I changing 4? Now I have 8 more, but I only changed 4 of them. Now, let's see. Let's see if we can do this visually. Now I have 15 men. And if I was to look the same up there for where there was equal number of women, would be there's 15 women and 15 men. Oops, one too many. There you go. 11, 12, 13, 14, 15, 16, 17, 18, 18. Excuse me, 18 men, 18 women. So now I have 18 men, I have 18 women boxed off in blue. And look at the excess. 4 and 4 makes 8. So you had to be kind of like visually also keeping in mind where the cutoff for equal men, equal women are. And of course, anything more than the equality of both men and women, that's the extra. So I mean, this is one you could have done graphically this way. Or later we'll do it algebraically. Whatever. We'll get there. All right. Okay, so now, hopefully you understood that one. Again, by diagram. Now I want to do one more. And you're going to go in the textbook on this one. And it is number 1, the inchworm problem. Inchworm problem. I'll give you a second to look that over. Actually, so problem set A, number 1, the worm's journey. And it's really one that it's hard to do algebraically. It really does do a sketch of it. But basically, what we have is a let's go with this guy. Let's go with have a 12-foot wall. There we go. There you go. 12-foot wall. So 0, 12, 6, 9, 3, 9, 10, 11, 6, 7, 8, 3, 4, 5, 1, 2. All right. And it says the worm is at the bottom of the 12-foot wall. Every day he crawls up 3 feet. So day 1, he'll crawl up 3 feet. But then at night, he'll slip down 2 feet. Question, how many days does it take the worm to get to the top of the wall? And so it looks like he had a net gain of a foot. All right, so every day he makes a foot. He's got to go 12 feet. I guess it's going to take him 12 days. Because he only makes 1 foot. So 12 days, right? Let's see. Let's take a look. Let's see. That's day 1. This was day 1. Day 2, he'll go 3 feet, so he'll make the 4-foot point. Then he'll slip back 2 feet. Yeah, that's day 2. Day 3, he'll go up 3 feet, so he'll make it to 5, and then backslide 2 feet to 3. Well, I mean, it looks like it's going to take him 12 days. So he keeps on going 1 day. Well, let's keep going. So up 3, down 2. Playing the room here. Up 3, down 2 ish. Up 3. This would be 1, 2, 3, 4, 5, 8. Okay, 8. Down 2. Up 3. That's a 9 foot. Down 2. Up 3. Now we're here. That's day 8. Down 2. Up 3. And we're at 11. That's day 9. Down 2. Ah. But now look at the next 3 feet. On day 10, because day 9, this is where he was at the end of day 9. He reached the 11th. He reached 11 feet, slid back 2 feet, but on the 10th day, he got his 12-foot height, and he's done. He won't slide back. So the answer here is going to be not 12 days, but 10 days. Alrighty. We went through a couple, 4 or 5 or 6 different, well, 1, 2, 3, 4, 5 or so different diagram strategies of solving a problem. This one, you got really, really astute for the algebraic one. You had to recognize that because it was 3 feet, you really had to get to 9 feet. How many days get 9 feet? And the last, which would be 9 days, 9 divided by 1. And then the last day, the 10th day, to get that last 3 feet. So unless you really were good at the visualization, the math behind it, sketching it out was really the best way of doing it. Let's see. What's next? Okay, well, that's pretty much it. For homework, so basically now and Friday, now on Friday, look at LP1 for problem set 1, which would be, again, let's go to assignments. Initial post, let's look at LP1 assignment. Okay, so question 1 is all B through E is chapter 2 stuff. I think you probably could get that done. And then there's no reason why you can't make a good attack or attempt on 2 through 5 there, which is chapter 1 problems, and see how it works. And on Friday, if you got any questions, we can cover it. Hey, what the heck were they thinking on that one? I don't know. I haven't done it yet myself. Actually, I did. I had all these problems done. This is a funny story. Maybe all this stuff was done, and at the end of the spring semester, I really felt I would never teach this class again. I was already kind of thinking of retiring. I tossed all my notes. Turned in the book, tossed my notes. So guess what? I'm doing homework again. So I feel your pain. What were they again? Let's see, what were those guys? What were those guys? Stone necklace. That's kind of sort of like the train problem. Dangerous maneuvers. Um, like dangerous maneuvers. Again, A, B, C. Use letters for each one, and then connect them. Like the ArcNet to K9 is one link that's 15 miles. Bopine to Lupine is a link. I hope I'm not screwing these guys up. I have to check it. I mean, I just and do like, yeah. I'm just gonna go in. Oh, they look good still. I mean, so like A to B was like 17 miles. A to C was like 8 miles. B to D was 2 miles. Let's just say that one. And they may want to know what's the shortest distance. Find the shortest distance from. Then the answer is, gee, what is B to C? Well, B to C is going to be look at the pathway. To get from B to C, I got to go to A first. Change colors. I need to go to A first, and then A to C. So A to B, and then B to C, and of course that's 17 plus 8 for 20. Dang. So A to B plus A to C, again 17 plus 8. All that line is how you would do that problem. The race. Yeah, 7 is going to be kind of like a ordering problem, and 10 is very similar to the worm problem. And number 10 is very similar to the worm problem that we just did. Come on. Why is this not moving? There you go. So, like I said, now on Friday, hang on one second. Do your best on answering these questions by the rubric. Okay. And we have questions on that one. Head of chat here. Are we free to do our own diagrams, or do we have to follow a pre-made one? Okay, we should. Okay, I remember. Want to verify what should we be working on before Friday? And are you changing? Okay. Yes, I'm changing due date. So Friday, definitely make your initial post on the discussion board on based about you. And I'll send out some extra information on what kind of question to answer. And for Friday, they're not due. However, we cut material for chapter 1. So between now and Friday, a good time to do chapter 1 work. So come Friday, if you had questions on it, we can answer them in class. Now we'll talk. And also that means everything you get done before the weekend is that less to do over the weekend, which I really like for me. I'm not quite sure what you mean by pre-made one. Referring to a pattern that I've shown. If you have another diagram that works, I mean, I showed a number of them. Is that all of them? Probably not. There's probably other ways of doing things. And if you find another way of doing it and it works, I won't penalize you for it, but it has to be a diagram. And it has to, like I said, meet these criterias. 10 points, clear, effective, communicates the important details, and makes the solution clear that I can follow what you're doing. Okay. That's chapter 2. This is part 2. So, yeah. So, like I said, I need to work on some dates. So, verbally, right now, for Friday, get your initial post in the discussion board. And like I said, it's not being collected, but I would say work on chapter 1, learning plan 1 stuff, chapter 1. And if you're really, 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 really enthusiastic, and kind of like look, I don't know, this is rubbish here. Look through these different, not that one. But I may want to look at, read through some Polia's readings here. Basically how to do a problem. I mean, a lot of what I was doing, understand the problem, that's like reading it, think of a strategy, carry out the strategy, and looking back means check your answers. Okay. That first problem saying the defined heuristic. The answers may be found in here somewhere. And these are PowerPoint presentations she's done in the past. Ooh, wow, looks like a definition there to me. Wow, that looks like a definition for heuristic. There's a worm journey, 12 days. Oh, that's, yeah. Different strategy of doing it. Another way of doing a sketch, graphically, electronically. Another sketch day. So many ways to draw up the sketch out a problem. $30 pages worth. Yeah, oh, okay, it's all systemic drawing here. All right. Looks the same to me. It's like a repeat. Okay, let's put this when we get into patterns. That's a later problem. That's a later chapter there. So, like I said, take some time, peruse through the learning plan 1, and like I said, we'll get through this together. The rubric is in learning plan 1. Yes, it is. Like every learning plan has a rubric on what I'll be looking for or what I need to be looking for when I look over the problems. Class assignments. I think this is learning plan here. Yeah, so here's learning plan 1 or problem set 1, and it's at the bottom of it. You go to learning plan problem set 2. Different problem sets, chapter 3 and 4, and here we go. Rubrics for chapter 3 and for chapter 4. So that each problem set will have a rubric attached to it, yes. And they're all different. Make life even funner. I think class is only the 4th. I think it's only the 4:15. Is that the schedule for it? Yeah, it's only the 4:15. Actually, I thought I'd be done early, but you also know I can talk forever. So yeah, so I'll send like I said, I'll put out a quick announcement on what my expectation for Friday is and what to do for the discussion board. But either way, hey, I'm talked out. I got another class that I got to do in about an hour, and I got to let my voice rest. Yeah, and so I'll see you all on Friday at 2:30. And like I said, 10 on Thursdays will go over any questions on problem set 1, chapter 1 stuff, and get through chapter 2. Chapter 2, they'll give you the weekend and work on those problems. And on Monday of next week, with opportunity to discuss any questions on it, and give it till like later that night to upload the results, the answers, because they'll be due on Monday. For this one, I think that's right for down. I modified it too. My intent is to have it for Monday, and we'll see how it goes. The initial post, your post on your specifics. Then you gotta go. Then you have like a week to go back and read them over, your other classmates over, and respond to 3 of them with something that you have in common. Problem set 1 is encouraged to be done on Friday. It's not due till Monday. However, there's 4 problems. The more, if we can keep up on these problems in real time, we won't have any bow waves. No, the Friday, the Sunday nights, or the Monday morning. Oh my gosh, I got all these problems to do. So let's try and spread them out. We'll do the 4 that we can do for Friday. Ask questions. If they're not done on Friday, you got the weekend still. But for Friday, it'd be great to have them that you can discuss them and basically get a good feel on understanding, I guess. Okay, I know what that means. Usually my kids say KK. So I'm assuming single K also means KK.
So it's just the 4 questions that are due on Friday, right?
Well, the point I would like you to make an attempt on. If they're
Okay.
done, great. That's that much less to do. If they're not done, okay, then you have questions or problems with them, we can go over them and get you over any issues, any questions you may have on it.
Sounds good.
Okay. All right. Let me stop the recording. Okay, and I'll stop recording.